Hello everyone. In this video we are going to discuss about the design and simulation of circular patch antenna using CST Studio. This is our tutorial number 20 on antennas and wave propagation. In our previous videos we had discussed about the design and simulation of rectangular as well as square patch antennas. So you can consult these videos for the better understanding about the basic concepts of inset feed microstrip patch antennas. The links of all these videos have been provided in the description of this video. As far as the design strategy of this circular patch antenna is concerned, the most critical design parameter is the radius of this circular patch, because width of feed line, length of feed line, and all the design parameters selection for the inset feed have been discussed in our previous videos. So let's learn how we can calculate the radius of the patch. These are the 4 simple steps. In first step, you can calculate the radius of the circular patch antenna from the rectangular patch antenna. And the rectangular patch antenna design parameters are basically the length and the width of the rectangular patch, and for that purpose you can use the length and width equations as well, and you can use online patch antenna calculator as well. But for the calculation of length and width of rectangular patch, you must need several values about the dielectric material. For example, you must know the dielectric constant and the dielectric height and the central frequency of your antenna. So for example, if I say that I want to design a circular patch antenna for Wi-Fi applications, so I will be using 2.45 gigahertz band, because it's a free band, and it can also be utilized in various applications. So the central frequency for that antenna will be 2.45 gigahertz, and obviously it is lower frequency band, and I can easily use FR4 substrate. So the dielectric constant and the dielectric height of the substrate will be used from the datasheet of the FR4 substrate. So let's use online patch antenna calculator, because it is little bit easier. So you can just type online antenna parameter calculator on Google, and these are the different websites that can provide you the calculation formulas for the calculation of length and width of rectangular patch. For example, I use the Pasternak website for the calculation of length and width of rectangular patch. So first of all, you need to define the dielectric constant value, and for FR4 substrate it will be 4.3. Similarly, if I talk about the dielectric height, then it can be 1.59 or 1.6 mm, and as we have decided that we want to design it at 2.45 gigahertz, so you can just click on calculate, and it will calculate the width and length of the rectangular patch. So now, after completing step 2, move toward the step 3, and step 3 requires the height of the substrate and the width of the substrate that we have already calculated in step 2, and similarly we need to know about the dielectric height of the rectangular patch. So all these values are known to us, so you can use this formula for the calculation of the radius of the patch. So W is simply the width of the rectangular patch that we have already calculated, and that width is basically 37.58 mm, and I have used the same value here. Similarly, DH is the height of the dielectric, and height of the dielectric is 1.6. Similarly, this is height or length of the patch, and the length of the patch is 29.14. So I have used the same value here. Similarly, dh is again the height of dielectric material. So after simplification, the radius of the patch should be 17.35 mm. So this is the strategy that you can adopt in order to calculate the radius of the patch. However, the basic concepts about the width of the feed line, inset gap, and the height of the inset, all these concepts have been discussed in our previous videos, and the links of all these videos have been provided in the description of this video. So you can just watch these videos to understand all the concepts about the calculation of these parameters. However, I will use the simple values that we have already calculated in our previous videos. So now let's move toward the CST, and just click on the new template, and you have to select microwave and RF, and you are going to design an antenna, and this is basically patch antenna. We will use the time domain solver, and these are the standard units. So our central frequency is 2.45. So for example, if I select the start frequency, our minimum frequency is equal to 1.5, and the max frequency will be 3.5, and obviously I will have to calculate E field, H field, and far field. The central frequency is 2.45. So just click and finish. So there are basic three steps of the microstrip patch antenna design. The first of all, I would like to design the ground of that circular patch antenna, and later on we will design the substrate of that antenna, and finally we will design the circular patch, and we will add the feed line to that circular patch. So first of all, go to the modeling and then just click on the brick, and you can press the escape key, and for example, if I start from the ground. So obviously if I talk about the maximum value and my reference point is 0, 0, then obviously I will start the design according to the radius, and as you know that the radius of the circular patch will be 17.35, and in most of the cases in different research papers we use the variable a for the radius of that patch. You can use r as well. However, x max will be the radius of this patch, and we can add some sort of gap for the substrate and ground. For example, if I add 5 mm gap on the x max side, so similarly you can use minus a, and you can add the 5 mm gap on the x min axis. So for example, if I talk about the y min, then obviously it will be again a, and I would like to add a distance of 5 mm in substrate and ground. While along the y min, obviously we will define the feed line as well, and I have to add the inset brick as well. So it will be minus a, and then I would like to basically the length of the feed line as well, and I use the value LF for the length of the feed line. So start Z min will be 0, and as you know that if we are going to use the substrate FR4, then the conducting surface have the thickness of 0.035 mm, and the material used for this conducting material is basically copper annealed. So just click on preview, and as you know that A is 17.35 as per our calculations, or you can round off it as 17.4. length of the feed line will be the quarter wavelength, and quarter wavelength for 2.45 gigahertz is around about 14.75. You can verify this value from our previous videos as well. So this will be the ground, and just click on OK. So now in next step, again go to the modeling and then select the brick. Now we have to design the substrate. So similar values will be used in the substrate dialog box. X min will be equal to -a -5. Similarly, y max will be equal to a plus 5, and this will be equal to -a minus LF. However, z min value, the starting point will be 0.035 from the top of the ground, and starting from the top of the ground we will further add the height of the substrate, that is 1.6, and obviously you have to change the material, and it is FR4. FR4 lossy will be used here. So just click on the preview and just click OK. So now you have designed the ground and substrate. So the next stage is the design of the patch, and you will use basically circular cylinder here, and just press escape key and name it as a patch. So its outer radius will be A, and X center and Y center will be 0 because we have used the reference of the 0 0. However, Z min will be equal to 0.035 plus 1.6, which is basically the top side of the substrate, and you will further add the thickness of the basically conducting material, which is copper annealed. Okay, so now just click on preview and just press OK. So this is basically the circular patch. Now you have to basically design the inset feed cut for inset feed line. So you can name it as inset feed cut. Okay, so if I talk about the inset feed cut, then along the x-axis, first of all we would like to add the width of the feed line. So half of the width of the feed line will be along the x-max, and similarly half of the width of feed line will be along the x-min, and along with the width of the feed line along the x-axis, obviously we need to add the gap of the inset feed, and you can use the variable GP. So if you want to add the gap on x-max, then you will just use plus GP, and similarly you can use minus GP along the x-min. So as far as the y-min point, then it will be -a, and starting from the -a, because this will be the bottom side of this circular patch, you will further add the inset height or inset length in it. So its reference point will be -a, and you will add the inset feed Fi in this inset feed cut, and the starting point will be same, 0.035 plus 1.6 along the Z min. Sorry, it will be 1.6, and you will further add 0.035 in it. And now you can use any sort of material. For example, if you want to use the vacuum, then you can use it, because you have to basically cut away the highlighted shape in the next step. So just click on the preview. Now you have to define the width of the feed line, as I already discussed. That width of feed line is very important for the impedance matching. You can watch our previous videos at how you can define the width of feed line. So it should be 3.13 for 50 ohms impedance with this substrate. gap. You can define the gap as per your requirement, and even you can change it during the optimization of the design. Initially I can use 1.5 as a gap, and then for example if I use 10 mm for the length or height of the inset feed, then this will be the basically inset cut. So just click on OK and then cut away the highlighted shape. So now the last step is the addition of the feed line. So you will have to define the feed line. So it will be very simple. Along the x max it should be WF by 2, and along the x min it will be minus WF by 2. Similarly, now its starting point will be minus a, because minus a will be the reference, and then you will further add Fi. So plus Fi, which is basically the height of the substrate. This will be the starting point, and from this starting point you will further add the length of the feed line. So the length of the feed line will be minus a, and then you will add further the length of the feed line. So just click on the preview. Okay, so before preview you need to define x min and x max values 0.035. Okay, so just click on the preview. So this is your length of the feed line. Okay, I think I forgot to define the material, and it is vacuum. So you can change the material. Okay, so assign material, and then you can change the material to the copper annealed. Okay, so now your design steps have been completed. So the last stage is that you can just add this patch with the feed line and then press enter. So this is your final design. Okay, so now you have to basically assign the waveguide port to it. So you can just rotate, and then you can just zoom in. Okay, so just press the shortcut key F to select the basically this feed line, and then go to the simulation, and then go to the waveguide. So its width should be 3 times the width of feed line on the both side along the x min and y min. Similarly, this is basically minus symbol, and we will use the value 1.6 because we are here at this point, and we have to touch to the ground. So this is the height of substrate, and we will be here at the bottom edge of the substrate, and further we will add the plus sign, but minus plus will be again is equal to minus, and we will subtract 0.035 value in order to touch the bottom side of the ground, so that it must be properly radiated. So the height of substrate should be height of the feed line should be 4 times the height of substrate, and height of substrate is 1.6. So just click on preview, and then you can just press OK. So that's all about the design of circular patch antenna. Now you can just start the simulation. Okay, so just click on the start simulation. So it will take some time to complete, and after the completion of the simulation of this design, we will discuss about the S parameter gain and the other results of this circular patch antenna. Okay, so simulations have been completed, and Now you can check the results. For example, if I check the 1D results and then S parameter results, then you can check here that if I add curve marker here, so it's round about -16. S11 is equal to -16 at 2.45. So if I change the value to 2.45 exact operating frequency, then these are -16.93. so these are the good results, and it provides better bandwidth as well. So you can further improve the results by changing the different values. For example, you can change the gap of the feed and length of the inset feed, and further, if your dip moves forward or move backward, then by increasing the size and decreasing the size of the radius, you can adjust the values of the dip as well. Similarly, you can check the far field results in order to check the gain at 2.45 gigahertz. So the gain is around about 5.99 dBi, or you can say that it is basically the directivity. So it provides the better directivity as well. So that's all about the design and simulation of circular patch antenna using CST. If you like the design strategy, then please like this video and subscribe our channel for the further videos. Thank you.